Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. If I will talk till where we have studied in the last lecture, we have seen some about new kind of circuits. About inductive circuit we have seen, capacitive and resistive circuit already we have studied, but in that also we have studied something, a lot of things that are new, like phasor diagram. We have represented EMF and current on phasor. First time we are doing this. Okay, how we have represented that? I've told you reference line x-axis we have taken as reference. Then if the angle phase is omega t, we have represented like this. If it is omega t plus phi, then we have represented like this. If it is less than omega t minus phi, then we have represented like this. Then three very important things that we have studied. Resistance. If I am talking about pure resistive circuit, current and potential are in the same phase. That means if EMF I am giving you E naught sine of omega t, that the current will be also I naught sine omega t. That means the phase difference is 0. Correct. If I am talking about purely inductive circuit, in that what happens? Current lags by an angle of pi by 2. That means if EMF is E is equals to E naught sine of omega t, current will be equals to I naught sine of omega t minus of pi by 2. Correct. And in purely capacitive circuit, what I have told you, that EMF will be is equals to E naught sine of omega t and current will be equals to E naught sine of omega t plus pi. Correct. So these three very important things that we have studied from the last lecture. I hope that you have watched that video. If you have not watched it, please go firstly watch that and then come to this lecture. Then you will be able to relate for everything. Okay. So we are starting from where we have left. So when we are discussing about all those things and when we are writing all those things, in purely resistive circuit, it was simply that E naught by R. Okay, but in capacitive circuit and inductive circuit, there are two different kind of resistance that we have watched. What was that two different kind of resistance? One was inductive resistance and one was capacitive reactance. Both will have the units as ohm. That means both have the property to resist. That means if let's suppose R and C are coming, that means what I will say, that resistance is always, its name is resistance, that means it is providing some resistance. But along with that, what I will say, that the capacitor that you will have, that will also provide resistance. Correct. That will also provide resistance. Clear? So and inductor also provide resistance. So the net resistance, that means the resistance provided by resistor, then capacitor, the inductor, the net resistance that you will be getting there, the net that you will be calculating, that net is called as now impedance. Now that net is called as what? Impedance. So the definition for impedance is the net resistance offered by the inductive circuit, capacitive circuit and the capacitive circuit, that is called as impedance, represented as Z. Here all these are purely circuits. Okay, so here what will be you will be called, if there is purely resistive circuit, Z is equals to R, simply it will be equals to resistance. If it is purely capacitive circuit, then what you will be saying, Z is equal to 1 by omega C. I hope that formula is remembered, 1 by omega C, if you remember that equation that we have written. And here Z is equals to omega L. Z is equals to omega L. Now SI unit will be again ohm. It is only about, we are talking about resistance. Interesting thing is what, sir, if it is purely resistive, it is very clear. If it is purely capacitive, then also it is very clear. But what will happen if I am combining these two? Then how much net resistance you will be offering? That is the actual question, and that is the next portion that we are going to discuss in that chapter. It is very interesting. Just be with me. So the first combination that we have taken in circuits is RC circuit. RC circuit. Okay, purely resistive and purely capacitive individually we have watched. What we have observed, again I am saying because it is a very important line, purely resistive circuit, resistance and current and potential are in the same phase. Capacitive circuit, potential lags, or you can say current leads by an angle of pi by 2. Correct? Very good. Now what I will see, now this is the AC source, always it is given as E naught sine of omega t, and let's suppose this is the potential difference across resistor and this is the potential difference across the capacitor. Potential difference across the resistor, potential difference across the capacitor. Okay, so if I have to represent all these things in phasor, potential if I have to, let's suppose, represent in phasor, I will take a firstly I naught, peak current that is flowing into x-axis. Okay, very good. Now if I am talking about the potential across the resistor, remember that, please remember that carefully. If I am talking about the potential across the resistor, what I will be doing, What I will be doing, students, if I'm talking about the potential across the resistor, I can say current and potential should be in the same direction, yes or no? If current and potential in the same direction, then only I can say that it is in the same phase. So I will draw it also in the same direction. This is potential difference across the resistor. Now what about the potential difference across the capacitor? I can say in capacitive circuit potential lags by current by an angle of pi by 2. So here what I can say, the angle between current and potential is pi by 2. So this will be the potential across the capacitor. This is what the potential across the capacitor. Fine. Now you have to find the result. 1 second. So if I'll ask you, tell me what is the net EMF of this circuit, how you will be calculating? कैसे calculate करोगे net EMF? See how we will be calculating that. I can say two vectors are in perpendicular direction. That means I can say resultant will be somewhat like this. Let's suppose represented as V. So if I have to write V or E naught square, that is given the resultant, because the net finally it is going to be equals to E naught. That is a net EMF that is produced here. So E naught can be written as VR square plus VC square, simple vectors. Okay. Now write. What you can write for VR square? VR square can be written as I naught square into R square. I naught square into R square. What you can write about VC? VC plus of I square into, what is the resistance offered by capacitor? It is represented as XC, that is capacitive reactance. And what you can write for I naught square, it is will be I naught square into Z. Z means what? The net impedance that is completely present in the circuit. What I can say, I naught square, I naught square, I naught square cancel. And what you can say about Z square, it will be Z square. Z will be written as R square plus XC square. Or further it can be written as R square plus 1 by omega C square. That is what I will not say to remember this formula, not at all. I will tell you a method, a much better method to apply. Just understand. And this angle is called as phi. This angle is called as phi, by which the current will be lagging, or the potential, in this case potential is lagging. So what will be defining tan of phi? Tan of phi is defined as perpendicular upon base. What is a perpendicular? Perpendicular is VC. VC, how you will be writing? I into XC divided by, what is the base? VR. VR, how you will be writing? I into, or I naught you can write R. I naught cancel. XC can be written as 1 by omega C into R. So tan of phi can be defined as, if someone asks you in the combination circuit, in a combination circuit of resistance and capacitance, how much this potential is lagging. So what you will be saying, sir, it is lagging by a phi angle, and phi angle is equals to tan phi inverse 1 by omega C into R. Correct? Is it clear? Now remember, from here I am giving you a short trick. Okay, you don't have to think that much. Okay, itna bas samajh lo. 3 representation I am giving you. Okay, 3 representations I am giving you, and that is valid for all the cases. Anyways, I will explain you from the basics, but always represent resistance in the direction of current, that is along the x-axis. Always, because it is always in the same phase. Because potential is always lagging by an angle of pi by 2 for purely capacitive circuit, इसलिए conventionally याद रख लो that capacitive reactance is always represented in the negative of y-axis. Xc is always represented as negative of y-axis, and simultaneously remember that XL, that is the inductive reactance, it is always represented in positive y-axis. It is always represented in where? Positive y-axis. Itna remember, yaad kar liye, then you don't need anything else. All the questions will be just simply solved on this basis. All the questions I will tell you that how to solve, because the game is about to calculate how you are calculating the G effective, Z effective, that means net impedance. Once you calculate net impedance, then there is nothing left that you don't know. Okay. So this will be the result. Okay. Phi, by what angle it will be lagging? So here phi, this angle will be defined as phi, and you will be just simply calculating VC divided by VR. Already we know these are basic things. So if you have to write the equation of current, how you will be writing? This is also one good thing. If you have to write the equation of current, this is the equation of EMF, and you have calculated this angle phi. I will be written as I naught sine of omega t. Now plus phi minus phi, how you will be judging that? It will be either plus phi or minus phi. Plus phi and minus phi is judged by that it is a kind of capacitive circuit. Still capacitance is in majority, that means current is going to lead. That means not by complete pi by 2. Complete pi by 2 happens in purely capacitive circuit, but it is leading by some angle phi, and that angle also I have calculated. I will be writing I naught sine of omega t plus of tan inverse 1 by omega c into r. This will be the result. I is equals to I naught sine of omega t plus of tan inverse by 1 by omega c into r. Clear? Now let's come to LR circuit. And let's see now what is happening with LR circuit. In LR circuit, who will be in majority? Now inductor will be in majority. And what is the behavior of inductor? In inductor, current always lags. Okay. So let's see from the basics. Again, I will say the same kind of things. I will say this is the E naught, that is a maximum amplitude. This will be the, let's suppose, the potential difference across resistor. This is the potential difference across the inductor. Correct? And now I want to calculate the net EMF I want to calculate. How I will be calculating? Pehle to represent kar lo. How I will be representing? Let's suppose this is some I naught current. This is some I naught current. Okay, very good. So if this is I naught current, what will be the direction of potential difference across resistor? I can say same, because they are always in the same phase. This will be VR. Now tell me what will be the direction of potential difference across the inductor. Always I have told you that potential leads by an angle of 90 degree. That means leads from what? Current. This is the direction for current. That means it will leads current by an angle of 90 degree, and this will be what? VL. And I have already told you the directions. Again, it will become that much only. See, E naught square. How you will be saying? It will be I naught square into Z square. It is equals to, tell me, कैसे लिखोगे potential difference across resistors? You will be writing I naught square into R square plus, कैसे लिखोगे potential difference across the inductor? I naught square into XL square. I naught square cancel. Z can be written as this time R square plus of XL square. R square plus of XL square. And how you will write XL? XL can be written as R square plus omega L square, because omega L is the formula for inductor. Correct? That means somewhere your resultant will be in this direction, resultant V or V naught will be in this direction, and this angle is called as phi. So agar equation will now, let's suppose if you want to write the equation of current, can I say potential this time is ahead of current, this is current, and potential is ahead by an angle of how much? Phi. That means how you will be writing current? Current will be written as I naught sine of omega t minus of phi, and how much that phi you will be writing? I naught कैसे लिखोगे? I naught will be simply written as E naught divided by Z, and Z कैसे लिखोगे? Z already you have calculated, R square plus XL square sine of omega t plus of phi. Phi कैसे लिखोगे? Tan of phi. Define tan of phi. Tan of phi perpendicular upon base. Perpendicular, what you will be writing? Perpendicular, this is I into XL, and here base it is I into R. So you will be writing I into XL divided by I into R. I cancel. Phi will be written as tan inverse XL divided by R. So same thing you will be writing here, tan inverse XL divided by R. This is the complete equation that you are going to write for the LC circuit. Is it clear? Is it clear? समझ आया? How we are writing? All the time we are doing the same thing. The trick that I told you, directly उसको भी कर सकते थे. Anyways, it is going to follow the same thing, because current तो cancel हो जा रहा है. What is only left? That is the resistance part. So directly represent now that this is your XL and this is your resistance. If there will be capacitance also, we will be representing that in negative y-axis. Simply solve the question. Correct? Because in the questions you are not going to do such, this kind of things, or when you are solving 20-25 questions, it will be automatically get stuck into your mind. Okay, that how to do these kind of things. Correct? Is it clear? समझ आया? Now let's move to the next one. All the things we have discussed, phi and everything. See, the general equation you will be writing will be minus of phi, and phi already you have calculated. Correct. Very good. Now, if it is a case for average power, how much average power you will be saying, sir, that how much average power is delivered? So power formula is what? Power is equals to E into I. Power is equals to what? E into I. So if you want to calculate average, let's firstly write the equation for power only, then we will see what is the equation, possible equation for average power. EMF equation is given here, current is also given here. कैसे लिखोगे? EMF is given as E naught sine of omega t into multiplied by current. Current is what? I naught sine of omega t plus of phi. This is what you will be writing. Now multiply E naught I naught outside, and after that left part is sine omega t into sine omega t plus phi. Sine c plus sine c into sine d. What you will be writing? 2 sine c plus d by 2 into sine of c minus d by 2. What you will be writing? Sine a into sine b. This is what you have to write. So you will be writing sine of a plus b by 2 into a minus 2. Multiply it. Firstly open it. Better than that, using this one, open this one, then automatically it will become sine of omega t into sine of a plus b. How will be writing? Sine of a plus b, sine a sine b into cos a cos b. So you will be writing sine of omega t into sine of phi plus cos of omega t into cos of phi. Sorry, I have written the wrong one. Sine a cos b into cos a sine b. Now see, cos of phi into sine of phi into cos of omega t. Now correct? Clear? Now multiply it. When you are multiplying it, it will be how much? E naught I naught as common. Multiply sine of omega t. Here it will become sine square omega t into cos of phi plus here it will be what? Sine of phi into cos omega t into sine omega t. Now the short trick that I have told you, it will be coming into use. Power, how you write? This is the equation of power. And now what you actually have to calculate? You actually have to calculate the average power. So take average everywhere. It will give you the same average. Here also average of this complete term. Here also average for the complete term. And average you will be taking for the complete time period. That means for omega t. Now remember, what is the average value of sine omega t? What is the average value of sine omega t in a complete circuit? Can you say it was equals to 0? First lecture, last lecture we have discussed it. Before starting this chapter only we have discussed this. And what is the average value of sine square omega t? Half. Exactly. So what you'll be saying when I am writing this, the average value of this much is half. That means you will be getting E naught I naught divided by 2. And what is the average value of this much? Here average value of cos omega t will sine omega t will be giving you 0. That means that complete term is 0. E naught into cos of phi. So average power is defined as this formula, E naught I naught divided by 2 into cos of phi. It can be further written as, because what I can write for E naught, it can be written as E naught by root 2 into I naught by root 2 into cos of phi. So it can be further written as, what is E naught by 2? Can you say it is nothing but E RMS then I RMS into cos of phi. This cos of phi is also called as power factor. This is also called as power factor, and the formula is R by Z. R by Z. Why I am saying that R by Z? इसको भी समझते हैं. Because in generally what happens, let's suppose this is net impedance. Somewhere this side it is coming. This would be, let's suppose, some XL, this would be some XC. And let's suppose this is XL is greater XL minus XC, so net impedance is coming in this direction and this is resistance. And this angle is defined as phi, correct? This is what the angle we define as phi. So if I have to define cos of phi, how I will be defining? Base upon hypotenuse. Base is what? R, and what is hypotenuse? Z. So this will be from here cos of phi. Power is equals to R by Z. So if I ask you, tell me when the maximum power will be coming. कब आएगा maximum power? When I say cos phi will be equals to 1, correct? When cos phi is equals to 1. So when it is possible that cos phi is equals to 1, let's discuss that case also. So can I say when Z is equals to R, that means if the impedance becomes equals to R, can you say cos phi will become 0? Can you say cos phi will be, because a lot of interesting things are here to discuss. Z is equals to R, cos phi is equals to 1. That means cos phi 1 is the maximum value for cos phi. That means can you say that time I am having my maximum power? That time I am receiving my maximum power. Clear? What will be happening if it is a purely capacitive circuit? What do you think? What should be the result? If it is purely capacitive circuit or purely inductive circuit as well, what is the value of resistance in those kind of circuit? 0. R is 0. Some impedance is there, that is a different thing, but some R is 0. If once it becomes 0, that means can you say my complete power factor is 0? If complete power factor is 0, what I can say, my average power is also at the same time 0. So the power that is offered in purely purely capacitive and purely inductive circuit, you have to remember how much? That is 0. That is 0. Clear? So a lot of things this equation is telling you, and actually it is an important result, so better if you are remembering this result as well. Correct? So for purely resistive circuit, I have already told you that it will be drawing the maximum for purely resistive circuit because power factor will become 1. Purely resistive circuit, that means when you are writing cos of phi is equals to R divided by Z. Z is also equals to R, that is the maximum value of R. For purely reactive circuit, it will be 0. No power is observed because when you are writing cos of phi is equals to R is equals to 0. Or there is a different way also to define, because what you will be writing cos of phi. Firstly calculate what will be this phi angle. When I am talking about purely resistive circuit, if this is the direction for current, what is the phi? Because it is in current capacitive circuit, current is leading by how much angle? Current is, this is the potential, and current phi is leading by an angle of 90 degree. For purely capacitive circuit, I have told you this is the potential, that means this will be the current, and it is leading by an angle of 90 degree. Here we are talking for purely reactive circuit. Okay, so vice versa, it is only mentioned reactive circuit, so capacitive also it is possible and inductive also it is possible. So inductive also the phi value is 90 because it is leading, current is lagging by an angle of 90, and in capacitive circuit current is leading by an angle of 90 degrees. So both the cases 90 is the same case. So anytime you are mentioning here either plus 90 or minus 90, anyways cos of 90 degree is always 0. You can there is a second idea to understand this thing. Otherwise simply understand that cos of phi is always equals to R by Z. So that means if you are using the purely capacitive or purely reactive capacitive circuit or inductive circuit, this resistance is equals to 0. Why this resistance will be coming? That means cos of phi again becomes 0. That means in that kind of cases, your power that is delivered, that is equals to 0. Correct? Very good. Now let's see the series LCR circuit. Are you ready for this? Are you ready? Should we start? We have discussed individually for everything. Now let's discuss for purely all the three combination. It is very easy. If I will tell you, it is very easy. See what I am going to do here. Let's start. Nothing special. Till here, is it clear that in what direction you will be representing inductive reactance XL? You will be representing it in positive Y direction. In what direction you will be representing XC? XC you will be representing in negative Y direction, and resistance is always represented in positive X direction. Correct? If these three things are clear, that means all of the things that you can derive from here. See how you will be doing. Finally represent everything in the directions. This is the direction for resistance, this is the direction for inductor, and this is the direction for capacitor. Correct? Now you have to judge that who is in majority. Either XL value will be greater than XC. If XL is greater than XC, that means it is what kind of circuit? Who will be in majority? It will be called as resultant will be called as inductive circuit. And if it is inductive circuit, who will be leading? Potential will be leading. But in case XC, now it will depend. If the values are given, it will be depending. If XC is greater than XL, then it is called as capacitive circuit. And if it is given, that means who is leading? Current is leading in that circuit by some angle of plus of phi. Okay, so these are the two probabilities that you will be having. So let's see one by one. All these things I have already explained you. You don't have to worry for these things. I will tell you how to solve. No need to worry for all these things. Okay, I have already told you. See, let's start from case 1. Don't worry for all those things. Case 1, it is given that VL, or you can directly say XL is greater than XC. XL is greater than XC. I have told you that if XL, first पहले तो represent कर लो. XL is greater than XC. Now it is the conventional method. If you want to represent by this way, that it is in the same phase, that's why it is written here. Inductive, it is always ahead of pi by 2 angle, that's why it is represented. I have already explained you all these things. So directly let's come to the point. That in positive direction XL is represented, in here it is resistance that is represented, and here it is XC that is represented, correct? And who is greater? XL is greater than XC. So I will say the net effect that is going to have, it is for inductive circuit. Then what I will be doing? I will be drawing the resultant. How two vectors in opposite direction can be written as? It will be written as XL minus of XC, XL minus of XC, and here it is already a resistance. Now if I ask you, tell me what will be the resultant that will be coming? Z, impedance Z will be coming, that will be root under R square plus XL minus XC whole square, XL minus XC whole square. And if I will ask you, tell me by what, and who is will be leading? Potential will be leading. It will be very simple for you. So how you will be writing that tan of phi also? Tan of phi also. Tan of phi will be written as perpendicular upon base. What is a perpendicular? Perpendicular is XL minus XC divided by the resistance, that is R. Or if you want to write in terms of phi, how will be writing? Phi is equals to tan inverse XL minus of XC divided by R. Simple. Clear? Now if I will ask you to tell me what will be the equation, what is the equation that you are going to use? So I will be writing that equation. Let's see, for case 1 only, if you have to write the equation, if inductive circuit is in majority, that means current will be lagging by some angle of phi. So if you have to write the equation also, you can write I is equals to I naught sine of omega t minus of some phi. What is I naught? I naught is peak EMF E naught divided by net impedance. How are you writing the net impedance that is offered? Net impedance you will be writing as R square plus of XL minus XC whole square. Now sine of omega t minus of phi. Phi how will be writing? Tan inverse XL minus of XC divided by R. This is the complete equation that you are going to write for the series results. No, nothing, not a single thing I will ask you to remember. Okay, all the things are so connected that you don't need to worry for the that how I will be writing that. Okay, all the things are connected by itself. Now the case 2. Case 2, same way. Now this time who is greater? XC is greater than XL. That means who is leading this time? It will be a capacitive circuit. Capacitive circuit, that means if you are writing the general equation of current, I will be writing I is equals to I naught sine of omega t plus of phi. That means it will be leading this time by some angle of phi. How will be writing the net Z? How will be writing that? See here. This is XL represented, this is R represented, this is XC represented. That means net will be written as how? This time XC is greater, that means it will be net impedance will be coming in downward direction. It will be what? XC minus XL this time, and it is R. That means net will be coming, Z will be coming in this direction, and that will be equals to R square plus XC minus XL whole square. Correct? And after that, just write it here. It will be E naught divided by root under R square plus X C minus XL whole square sine of omega t plus of tan inverse. What will be saying? Perpendicular is XC minus XL divided by the base, that is R. So now you can write everything here. You can write everything literally. whatever it is asked in the question, just you can even write the complete equation. Once you understand how to write the complete equation, that means nothing is left more to write. Correct? Now if you are able to write the equations completely, then what is left? Easily you can do everything. Clear? So this is the case for combined circuit. Now there is a question, try to solve it. Let's try to solve it. See, in the given circuit, the reading of voltmeter V1 and voltmeter V2 are 300 volts. Voltmeter V1 and voltmeter V2 both are 300 volts, okay, each. The reading of the voltmeter 3 and the ammeter A are respectively. What will be the reading of the voltmeter 3 and ammeter A? This is the ammeter that you have, okay. कैसे solve करोगे? Let's solve it here. See, firstly what you will be doing, you will be calculating the this current. How will be calculating? Current, for calculation of current, what you will be doing? Current will be written as E naught, that is the peak value, and dividing by it by the you can calculate for anyone, because what I can say that net current flowing through inductor and net current flowing through capacitor and net current flowing through the inductor, all these three things are same. If all the three things are same, you can calculate across anyone here. So what you will be doing, that calculate current. Before that also you have to calculate what will be the EMF across this VL. Before that, calculate the EMF across VL. Then you can easily calculate, because this resistance are not given, here resistance is given. So for calculating EMF, the net EMF is going to be E naught is given as 220, and across this one it is given as 300, across this it is given as 300. So it is easy. How you, in what direction you always tend to represent the potential in across the inductor? I can say in positive axis 300 volt. In negative axis, capacitor is also given as 300 volt potential. Both are given same. That means I can say simply they are going to cancel out, and in a resistor, across resistor you have to calculate VR. So I can say simply it is going to cancel out. That means resultant is itself coming towards the resistor. That means it will be how much? 220 volt. Simple. Correct? 220 volt. That means the resistor will be having 220 volt. If you got the potential, you can calculate the current. Current will be VR divided by the resistance. It will be 220 divided by 100. Answer will be 2.2 ampere. Simple. Clear? So answer will be, which option is coming correct? 220 and 2.2. That means option B is coming correct. Clear? This is the I have told you about case 1 when XL is greater than XC. When I have told you about case 2, that is XC is greater than XL. But now the case 3, that will be resonance condition. What we call this resonance condition, when XL is equals to XC. When XL is greater than XC, it is a kind of purely resistive circuit only it remains, because now when you are calculating phi, it will be equals to, or you will be calculating impedance, it will be equals to R. Okay, so there is one term, just remember, whenever there is a resonant condition, remember one thing, that XL is equals to XC, and there is a term or resonant frequency. How will be calculating? XL is equals to what? Tell me. Omega L, and XC is equals to what? 1 by omega C. That means omega square can be written as 1 by LC. That means omega can be written as 1 by root under LC. This frequency is called as resonant frequency. This is one important term that you have to remember. Resonant frequency is equals to 1 by root under LC. A lot of times it is also comes in units and dimensions as well. Okay. Now the topic, last topic we are in for this chapter, that is transformer. In the last chapter also, when we were talking about the application of electromagnetic induction, then also we have discussed about transformers. So it is from your board points of view, it is also very important, and that's why I have given you complete diagram and everything. There are two kind of transformers. Now understand transformers. Transformers are used to step up the voltage, output voltage, and step down the voltage. Now what is the meaning of this? Okay, transformers. A device used to step up or step down AC voltage by using the concept of mutual induction. This was the concept of mutual induction only. This is the diagram that you will be having for transformer. Maybe you would have seen transformers also. Why actually it is this? And there are two kind of transformers: step up transformer, step down transformer. Actually, to reduce the power loss, we use this. Okay. Because a lot of times what happens, our houses or the cities are far away from the place from where current is coming, power stations basically, if I will say. So when you want to decrease this power loss, that's why we used a transformer. I will tell you the complete setup also, but firstly understand what is the setup for transformer. Okay, see, this section, it is divided into two sections. One section is called as primary coil, and one section is this section is called as primary coil, or also this is the input side. All the inputs we are giving from here. This section is called as secondary circuit, and this is also called as output side. Some current is coming here, it is the wire, and here it is current as iron core. There is iron core. Due to that, what happens, here is the flux that will be generated. Current will be changing, and due to that, what will be happening, flux will be generated, and the same flux will be transferred here as well. The same flux will be transferred here as well, because they are connected, and the same flux that is passing from here, it is going to create the same flux that is passing from here. And if there is change of flux, there will be some, what will be happening, EMF will also be generated, correct? Now due to the change in flux, EMF Faraday's law, it will be simply, I will explain you on the actual diagram that you have to draw in the exam. This is the actual diagram that you have to draw in exam. See, this is the supply, that means I can say this is the input side. This is that turns that were represented there. This is number of turns in primary circuit. This is the secondary circuit. This is the cross section after which it is divided. This is primary circuit. All the parameters is written as P, and this is the secondary circuit. All the parameters are written as S. Okay. Laminated core. This is the laminated core, and it is secondary winding. This side, this is the secondary current, and this is the secondary, or this is also called as output side. This is also called as output side. Now whatever the flux that will be generated here in the primary circuit, that same flux will be transferred here. See, it is a representation for the flux also, that same flux is transferred here also. So this is the concept. You remember what was happening in mutual inductance? If two coils are kept very close to each other, if flux is changing in one and the same change in flux is passing in the, because of flux lines are there, so those flux lines are passing through the second one also. Due to that, what will be happening in the second flux? Anyways, its current is also not changing, nothing is changing. Still, if nothing is changing, magnetic field is not changing, still some EMF will be induced, still some current will induce in the second loop also. That phenomena is called as mutual inductance. And same thing is happening here also. Here some EMF will be induced and some change in flux will be coming, and due to that change in flux, some EMF will be generated here as well, correct, in the secondary part as well. Now how will be coming to the results, that you understand. See, first result for that, what you will be doing, tell me what will be writing flux. How will be writing flux? Let's suppose flux will be writing as phi. Flux will be writing as phi, and same flux is pass on here, let's suppose phi. But number of turns are there. I have told you, whenever you are writing flux, you will be writing multiplying it by number of turns NP, and here you will be multiplying it number of turns NS. So now if I will ask you, tell me what will be the EMF you will be writing on the primary circuit. What is the EMF you will be writing on the primary circuit? What you will say, sir, EMF, it is defined from Faraday's law, that it is minus of or mod liglo d phi by dt. So differentiate it. What will be differentiating? You will be writing NP d phi by dt on this side. And if I will ask you, tell me what is this ES, secondary EMF, ES will be written as, again differentiated. So you will be writing NS d phi by dt, NS d phi by dt. Now what you will be doing, take the ratio of EP by ES. EP by ES, what will be coming? Can you say this d phi by dt and this d phi by dt is going to be cancel out, and what will be the coming resultant? It will be NP divided by NS. This is one important result for question solving that will be trying for board students. You have to draw this complete diagram, every single thing you have to represent here. Then you will be coming to this part, that first result that you will be getting from here is EMF that you are having is directly proportional to the number of turns on both primary and secondary circuit. Why it will be coming into use, that also I will tell you when we will be studying about step up and step down transformer. Here is the result that you are having. Okay. Now let's discuss about some ideal transformer as well. Ideal transformer means what? That efficiency is equals to 100%. That is not a practical case. In practical cases, even if you are achieving 40% of the efficiency, that is considered very good. That is a very good efficiency. But still, in physics, we study a lot of things that are ideal. So we'll be studying only about the ideal. So efficiency ideal means what? Whatever the input that you have created, it will be coming to the output as well. Whatever the input that you have created, it will be coming to output. That means I can say input power, whatever it is generated, that is equals to output power. What is the meaning of input power? How you can write EMF of secondary circuit into current of secondary circuit, and what is output power? EMF of primary, it is input side and secondary is the output side, secondary circuit. From here, if you will be taking the ratio EP by ES, what you will be getting? EP by ES is equals to, EP by ES will be equals to IS by IP. That means I can say EMF and current are inversely proportional. Even you know, that means I can say it is also directly inversely proportional to, current is inversely proportional to number of turns, because number of turns is directly proportional to EMF. So this is the complete result that you have to remember. This is the case for what? This is the case for ideal transformer. So if you have to write the efficiency, this is the representation for efficiency. How you write efficiency? Efficiency is written as, let's suppose you have given for our example, let's suppose a power input that you have given is 10 watt and the output that is coming from there is 5 watt. That means what is the efficiency? You have given 10 watt and the output that you are getting is of 5 watt. That means what you will be saying as efficiency percentage, output divided by input. Output, that is 5, input divided 10, that is 1 by 2, and in percentage if I will ask you, you will multiply it by 100. That means what is the efficiency of my machine? 50%. Exactly, that is what the same thing. Efficiency is defined as output power divided by input power, and if you want to write in percentage, multiply it by 100. So if someone asks you, tell me what is efficiency, you will be writing what? That here efficiency, output power, I will be writing ES IS divided by input EP IP. Correct. And that's why I've told you that it is efficiency is 100%. That means here it will become what? 100 divided by 100, it will be equals to 1, and you can say that ES IS is equals to EP IP. Exactly the same thing we have seen for ideal transformer. Clear? These basic things you have to remember for transformer. Okay. Now, first thing is step-up transformer. Where these step-up transformers are used, as understand from a diagram here. Let's suppose you are here. It is a power station. Okay. Here it is a power station, and here it is a transformer that is connected. Let's suppose here is a transformer, and again here is a transformer. This is your home till where current is coming. Okay. This is a point where current is coming. So what you do, I will say that a lot of high potential currents are generated here. High potential voltage is generated here. So what we do, we use a step up transformer here. What we do, we use a step up transformer at this place to increase the potential. Okay, to increase the potential, you can see the secondary EMF will be step up transformer. This is the step up transformer. What we are trying to do, we want to create the output as the higher. We create output potential higher than the input potential. So due to that, what will happen? Current that is going to go in the output will be decreased. Correct, because EMF and current are inversely proportional. That means the current that is flowing will be decreased. If the potential is very high, current will be low. If the current is low, what I can say, actually power loss is defined as I square R. R resistance you cannot control, but if you are decreasing this current, in my, because this is the very large distance, if the large distance is there and power loss is very high, that means we will not be able to retain the generated power also. Okay, so due to decreasing that, we always do what? We increase the potential here. This is the output, this is the input, and firstly what we do, we increase the output, then the input. Correct. Now coming to our houses, this is very high potential line. 10,000 volt, 12,000 volt, this kind of. But if it is directly coming to your house, you know that what will be happening, everything will be just blast in a moment. So we cannot allow directly that current to come to our houses. That's why we use the second kind of transformer, that is called as step down transformer. And step down transformer did what? It will be converting this EMF, higher EMF in equals to 220 volt, that is coming into our houses, and that's how this complete setup is working. So to decrease the power loss, that's why we use two kind of transformers, step up transformer and step down transformer. Step up transformer is always near the power stations, and step down transformer is near to our houses, our colonies, our cities. Okay, step down transformers are present there. So if you have to write the condition for step up transformer, how you'll be writing, let's discuss that as well. I will say that this is the output side, this is the input side. Step up transformer means what? That EMF of secondary circuit should be greater than EMF of primary circuit. And if it is the case, I will say that number of secondary circuit should be greater than number of primary circuit. Number of secondary circuit should be greater than the number of primary circuit. Okay, sorry, this is the page of step down transformer. Sorry, here you will be writing EMF of secondary step up transformer. EMF of secondary circuit is greater than EMF of primary circuit. That means number of turns in secondary circuit is greater than number of turns in primary circuit, and vice versa you will be saying for this case for step down transformer. That means this time you want that the secondary circuit output should be lower and input should be already coming higher. That means input is greater than output. That means number of primary circuit, number of turns in primary circuit is greater than number of turns in secondary circuit, because it is directly proportional. So some power losses are there that you have to study. This is given in NCERT in complete depth. You have to read from there about power losses. There are flux loss, flux leakage. Actually it should be written as leakage, flux leakage, resistive loss. So and how to minimize those losses, that is also given in your book, so you read out it from there. That is a thing. Now there is a question, try to solve it. See what is the question. On basis of the transformer, a transformer having efficiency of 90% is working on 200 volt. Okay, it is working primary circuit, it is 200 volt, efficiency is 90%, and 3 kilowatt power supply, and 3 kilowatt power supply is also there. If the current in the secondary coil is 6 ohm, if the current here it is 6 ampere, and the voltage across the secondary coil and the current in the primary coil respectively are the voltage across the secondary circuit. What will be the voltage across the secondary circuit that you want to calculate, and the current in the primary coil respectively. In the primary coil, what will be the current? This is how much value that you have to calculate. So how you'll be doing that? Let's see. These are the options that you'll be having. See, let's solve it here. See, but values is such a why solve it. Solve it here. See what you can say. Efficiency, that is 90%. It is equals to what you'll be saying, output power divided by the input power. Correct? What we'll be saying about now output power. Output power can be written as 90%. That means how much you will be writing? It as 90 by 100. That means you will be writing 0.9 into 3. Input power is given as how much? The input power is given as 3 kilowatt. That means what you'll be writing? It is 9 into 3, 27. That means 2.7 kilowatt. That is your output power is. Output power is how much? 2.7 kilowatt. This is the first thing. And how you can write the output power? Output power is the secondary circuit. That means ES into IS. ES into IS, that is written as 2.7 kilowatt. How you writing that? ES, that is what you have to calculate also. IS, current is given as 6. That means it is given as 2.7. That means EMF in secondary circuit can be written as 2.7 divided by 6. There it is kilowatt. That means it will be 10 of 3 as well. Correct? That means kitna EMF hoga? If you want to calculate EMF in secondary circuit, it will be how much? It will be 2700 divided by 6. If you are directly cancelling it from 3, it will become 900 divided by 2. That means EMF in secondary circuit will be, I guess it will be equal to 450 volt if calculations are clear. check it once again. That is the first thing. What is the second thing that you have to calculate? Current in the primary circuit. Current in the primary circuit, how will be calculating? You know the input power. Input power is equals to 3 kilowatt, that means 3 into 10 power 3. It is equals to IP into EP. EP is equals to how much? 200. This will be cancelled. That means IP will be equal to, this will be 15 ampere. 15 ampere. Here it will be equals to how much? 15 ampere. Check if any option is matching. 15 and 450. 15 and 450, option B. 15 and 450 are the options that will be coming correct. Obviously, the formula that we have studied, it is coming from the same formula. So I hope that you have enjoyed this chapter. You have learned a lot of things new. We have covered all the basics, and about the question solving, we will be taking the question series along with this. So all the doubts will be clear there about regarding the questions, what kind of questions are coming in NEET exam, JEE exam. Boards, about boards I have given you idea overview, so you can take the reference from there. So until next time, keep learning, keep growing with Tapasya. Endigu, endendigu, Nama Tapasya.